Hi, welcome to lesson 1.12. Alright, so you already have all of the necessary skills to tackle all of these problems, and so why don't you go ahead and try this one on your own so that you can kind of figure out the methods by which we can accomplish this aim. Make sure you copy down the whole problem, including the graph, and answer each question on your own. Alright, so let's start by thinking about the relationship between the two functions that are graphed. And right in the question there's kind of a hint, right? If it's asking what the relationship is, that kind of implies that there is some relationship between the two of them. So if you're looking at these two quadratic functions, what could be the relationship from one to the other? Or in other words, how could I go from one of them to the other one? And what you might notice is either thinking about how you would manipulate the blue function in order to make it look like the red function, then you would be thinking, oh, maybe I could translate that function downward. If you were thinking about making the red function more like the blue function, then you would translate it upward. And so what you're getting at is that the relationship is that one has been translated in order to form the other one. Alright, which function represents the function y equals 2x squared plus 3x plus 6? And how do you know? Well, if I look at this equation and then I look at the two graphs here, the two curves, what's the glaring difference that might help me figure this out? Well, clearly one of these does not have real roots, has complex roots, while the other one does have real roots. In other words, one is going to intersect the x-axis and go negative at some point, and the other one will never intersect the x-axis and will always be positive. So there are a couple different ways that you could actually ascertain which function is represented by this equation here. And one way is to actually solve for the roots, so to set y equal to 0 and solve for x, and then check the discriminant. And that would tell you whether or not you're going to have real or complex solutions, or complex or real roots. Another way is to think about what we know just about this function by looking at it, right? We have a positive value here for our a coefficient, a positive value here for our b coefficient, and then a positive value here for our c coefficient. And so if you're thinking about, well, is there any way that this could ever actually be negative? It doesn't really seem like it, right? We could also go about and try graphing a couple of points to check. So if you plug in 0 for x, you'll notice that you get a value of 6. And if you check both of these curves, only one has a value of 6, y value of 6, when the x value is 0. That's going to be the blue curve. Now the last question is interesting. Other than translation, what transformation would cause the blue function to have real roots? So notice that if we translated this blue function down, in fact if we translate it down what it looks to be 10 units there, or actually no, 8 units, I apologize, 8 units downward, that would give us the red function, which does have real roots. One other transformation that would accomplish this is to think about, well, what could we do to this function that would all of a sudden force it to intersect the x-axis? And if we can't translate it down, that means we sort of have to turn these ever so extending arms upside down. In other words, reflect it. So we could multiply by a negative, or change the a value to a negative, which would reflect our curve and turn it upside down, ensuring that it then had real roots. Okay, so what can we do if we're faced with a quadratic function that doesn't have x-intercepts? And it's important to think about what this means. If it doesn't have x-intercepts, it means it doesn't intersect the x-axis, which means it has what kind of roots, right? This will mean it has complex roots. Alright, well, what can we do? let's first envision what this type of function will look like. So there's a couple of possibilities, right? It could open upwards and be above the x-axis, or it could open downwards and be below the x-axis. And so what I'm doing is I'm representing the examples of complex roots, functions with complex roots in green, and then we'll talk about the different transformations that we could do that would allow them to have real roots. So the first and most obvious one is that I can translate the function. Right? And what will that look like? So remember, a translation up or down is where we are influencing the k constant, right? And so, for example, if I were to have f of x, the way I would need to manipulate it is by subtracting some value k, right? That would shift it down. Or if I were working with the function g of x, I would need to take whatever g of x is, and I would need to add some k value, right? Now, it may be the case, right, that these graphs already have a k value built in, right? So f of x may already have a k value of 2. So what I would need to do is subtract a new amount that would be enough to take it down below, okay? Or, for example, g of x may already have a k value. So this is included in the function, and then what I need to do is add to it so that it will then be shifted or translated upwards and intersect the x-axis. Okay, so let's just use one of these as a brief example so that we can hopefully get a better idea of what this will look like. So let's say that g of x, let's define g of x to be x plus 3 squared minus 2. All right, so here, let's just say that we've counted the number of units that we need to move it up, and the number of units that we need to move it up so that it intersects. Let's just say we decide that we want to shift it upwards 3 units. So we're going to add k. So what we want is now g of x plus 3. What will that look like? Well, it will be exactly this, plus 3 to it. So it will be x, oh, sorry, and there should be a negative out front. Negative x plus 3 squared, and then negative 2 plus 3 is going to be plus 1. Okay? And so that's an example of where I take a function that does not have an x-intercept, and I shift it or translate it so that it does. All right, what's one other possibility? Notice that we talked about how you could reflect either of these functions, and if we reflected either of them, then we would end up with functions with real roots or x-intercepts. Alright, so how could we reflect the function? Well, there's a couple of ways that we can do this. The most obvious is to change the a coefficient from positive to negative, and if we simply do that, then our function will reflect over its vertex. Okay, so what we could say is, if, for example, we have g of x again, simply manipulating it so that we now have a new function, let's call it h of x, where we change the a value from negative 1 to positive 1, and so now we had x plus 3 squared minus 2. This function would reflect over its vertex and would now have real roots. There's one other way that we can reflect the function, and that's by not just changing the sign of the a value, but actually by multiplying the whole function by a negative. And what that would do is reflect it over the x-axis. But notice, if we reflect this over the x-axis, we won't necessarily have real roots, right? Now, in fact, we just have the same situation, but on the other side. So you might want to note that we're not actually multiplying the whole function g of x by a negative, because that would be reflecting our function over the x-axis. And the reason is that that negative would also affect the k value of -2 and make it a +2, which would make this reflection always positive. So to reflect the function over the vertex, which is what we want to do, over the vertex, we need to change the sign of the a coefficient. Okay? And so those are the two ways that we can take a function, a quadratic function, that does not have x-intercepts, meaning it has complex roots, and turn it into a function that does, in fact, have x-intercepts or complex roots. One thing that I do want to make sure that that I mentioned is that when I underlined x-intercepts, I should have underlined also the doesn't have part, because doesn't have x-intercepts is another way of saying it has complex roots. Alright, now it's time for you to complete a couple problems on your own. Alright, so here are 3 problems for you to go ahead and complete. Make sure that you show all work or explain any answers that you choose, so that you're ready to go and explain your work.